Hey guys, welcome back to our channel. In this video, I will discuss some of the basic MATLAB Simulink blocks that are most commonly used while doing model-based development. Well guys, if you are into model-based development, mastering Simulink is a must. Whether you are designing control systems, simulating dynamic modules, or integrating automotive features, Simulink provides powerful blocks to bring your ideas to life. Well, let's get started. Hey guys, first we will go with different types of source blocks. So let me go with one of the source block that is constant. Wait, let me type source blocks here and just I will increase the size and I will keep it here. Well, so first we will go with constant block, and if you want to display the label, just click on this three dot and and check on this option. So this is the constant block. Well, the purpose of this block is to produce a fixed scalar or vector value during the entire simulation, and it is ideal for setting initial conditions or providing reference values, and it can be dynamically tuned without relearning the simulation. And guys, it supports scalar, vector, or matrix values, and it is most commonly used in parameter sweeps and control systems. Well, let me run this. Now the constant value is 1, so I will take the display block so we can display the value. And now I will save this simulation and I will run it now. So it is compiling and you can see the value is 1 in the display. Now I will change the value to 5. So you can see the value right now in the display, it is 5. So I will change the dimension of the block like 2, or with the help of square brackets you can change the dimension of the value. So it's now here you can see it's 1 cross 4 matrix. Now let me run this. Well, here you can see the value. Well, this was about the constant block. Let's move to second source block, that is step. Let me search step. So this is one of the source block, and let me click on this three dot and show the block name. Well guys, it generates a signal that changes from one level to another at specific time. You can mention the time, and you can also set the step time, initial value and final value. And it is useful for testing the transient response of control systems, and you will get the customizable parameters like if you click on this block you can find the parameters, you can customize it, and it simulates a sudden change in input conditions, and this block is frequently used in disturbance testing and PID tuning. So let's take one scope and wait, it's loading. Well, I will connect this scope to this step block and I will save the simulation, and let me run this. I will double click on this display. Here you can see the result. This is the step wave, and you can also change the like step time, and you can also set the initial value and sample time you can set. So let me delete this and keep it aside. Now let's move to next source block, that is pulse generator. Pulse generator. Yeah, this is the pulse generator source block, and so it produces a square or rectangular waveforms with user defined amplitude and frequency. Well, you can define the amplitude and the frequency of this block, and it includes customizable parameters like amplitude, period, pulse width, phase delay, and it is useful for testing digital systems or triggering events. And it generates a repetitive signals suitable for clock-like behavior, and it supports periodic signals for PWM and timing analysis. So this was about the pulse generator. We can connect this to scope and actually see the results. So let me take a scope block and connect this to the pulse generator. I will save this simulation and let me run this. So well, this is the result, and here you can still change the time based. So it is 10-second period, amplitude 1. So pulse width is 5. We can make it some other value and run the simulation. So here you can see the result. The phase delay is 2, and so this is the result of this pulse generator. So let's move to other source block, that is sine wave. I will keep this aside. Sine wave. So basically this block it is used to generate the sinusoidal wave form. Okay, well, it produces a sinusoidal signal of specific amplitude and frequency. Again, if you double click here, you can change the frequency and amplitude, and it is useful for modeling a periodic inputs like AC voltage or oscillatory systems. It can include phase shifter to simulate delay sine waves, and it supports continuous and discrete modes of operation, and it is most commonly used in resonance and vibration system testing. Well, this was about the sine wave. Let me connect this to the scope again just to check the results. So right now the amplitude of this block is 1 and frequency is 1. So let me run this. So here you can see the result. Okay. Let me delete this and keep this block aside. Okay, the next source block is the signal builder. Signal builder. Maybe we don't have the library for signal builder. You can just search on Google. You will get the signal builder details. Well, this is the signal builder block. It is very useful, like it enables the creation of custom signal waveforms through a graphical interface. You can create a custom waveform with the help of this block, and it supports multi-dimensional signals for complex input profiles, and it facilitates batch simulation with different signal vibrations, and it is useful for testing real world scenarios with irregular inputs. Like if you want to develop a drive cycle, then you can, with the help of this signal builder, you can develop a drive cycle, and this block is useful in various applications where the inputs is dynamic, where the input is dynamic. Well, and in this block you can save the signal and you can reuse across different models. Well, this was about the signal builder. Let's move to next source block, that is ramp. Okay, let me search ramp. Okay, this is the ramp block, and wait a minute. Yeah, So it generates a linear increasing or decreasing signal over time, and it includes parameter like slope, initial output, and initial start time. Okay, and it tests the system behavior under gradual input changes, and it is commonly in velocity profile testing or and in ramp up behavior, and it simulates real world scenarios like motor acceleration. Okay, let me connect this to the scope. You can just see the results. Okay, and right now the slope is 1 and start time is 0 and initial output is 0. Okay, let me run this. Well, here you can see the output of the ramp block. Okay, even you can change the start time. Just initial output will keep it 1. Okay, start time let it be 0. So from 1 it is starting, and if you want to change the start time, so we can make it 2. From 2 seconds it will start the ramp. Yeah, here you can see. Well, this was about the ramp block. Well, guys, these are the different types of source blocks. These source blocks are very commonly used while doing model-based development, and you must know each and everything about these blocks. Well, guys, let's move to sync blocks. Okay, the second set of blocks are sync blocks. I will type sync blocks. Okay, sync blocks. Okay, the first one of the sync block is scope. Here we can see the actually the results of blocks. With the help of scope block we can see the results. Well, it displays the signal behavior over time in a graphical format, and it supports a single or multiple signals in one window, and it enables live monitoring during simulation, provides option for zooming, scaling, and detailed analysis. You can see here options for zoom, and you can also scale the results. So some other options also there. You can later like explore those options, and it is primarily used for debugging tool for dynamic systems. Well, this was about this scope block. Let's move to next block, that is two workspace. So this is the two workspace block. Let me click on this show block name. And if you want to save the results to your workspace, then you can use this block. So like this is the workspace for this simulation. Here you can see the workspace. If you want to store the variables or the output, then you can use the to like workspace block, and it is basically used to export signal data to MATLAB workspace for further processing, and it stores the data as array structures or time series objects, and it facilitates post simulation analysis like plotting, and it allows MATLAB scripts to manipulate and analyze results. Well, it is most commonly used for automated testing and data logging. So this was about the two workspace block. We can actually save some data. I will take this constant block. I will copy this and I will connect this to the workspace. Okay, let me save this simulation and run it. Let's check whether it is saved or not. So double click on this. I think it is saved the data. So with the help of this to workspace, you can save the data to your workspace and you can further analyze that data. So let's keep it here and let's move to next sync block, that is display. Okay, this is the display block, most commonly used if you want to display some parameter value. Okay, it shows the value of scalar signals during simulation, and it is useful for monitoring key parameters without additional plots and limited to scalar values for simplicity. Ideal for debugging and quick check, and can be replaced near critical points for real-time observation. So it is very useful if you want to monitor any particular value. Let's move to next block, that is to file. Yeah, if you want to convert the data into .mat file, then this block is very useful. It saves the simulation data directly to a .mat file, and it facilitates long-term storage and sharing of results. It stores the data in a structured format for easy access. It supports automatic overwriting or incremental naming, and it is ideal for large-scale simulations requiring detailed logs. So this was about the .mat to file block, okay, which saves the data into .mat format. And let's move to like some of the mathematical operations. There are some blocks which are useful for mathematical operations. Let's discuss about it. Mathematical operations. So let me increase this size of this text and I will keep it here. So let me search one of the mathematical block which is useful for mathematical operation, that is gain. Okay, this is the gain block. Okay, let me increase this size so that it will be useful for you to understand. Okay, it multiples the input signal by a constant gain value. So suppose if the input signal is 2, it will multiply that signal. The output will be 2 into 1, it will be 2. If I change the gain value as 2 and the input value is 4, so output will be 8. Like it will simplifies the scaling operation in control systems. Basically it will simplifies the scaling operation, and it will accepts the scalar or vector inputs for different dimensions, and it supports time varying gain when combined with other blocks, and it is most commonly used in amplifier modeling and proportional control. Okay, let me test this. I will take one constant block. Okay, the value of this constant block, I will keep it 5, and the gain value I will keep it 10. So it the gain, the value which is here 10. So basically gain block will multiply the signal value. Now it is 5, the signal value is 5 and this value is 10. So 5 10 it will be 50. Let's connect the display block here. So the result will be 50. Just run the simulation. Here you can see the value is result is 50. I will change this gain value to 2. Now the result will be 10. So here you can see the it is 10. Okay. Wait, let me adjust this. Okay, let me delete this. This was about gain block basically. Let's keep it aside. Next, move to different mathematical operation block, that is sum. Let me search sum. Well, this is the sum block. Let me increase the size of this block. Well, basically this block will adds or subtracts multiple input signals based on the configuration, and we can also configure this with the different signs. Here you can see the list of signs. If you want to add minus, you can add it, and you can also add multiple values. So let me keep 5 plus. So here you can see you can add the multiple signals. Let me make it default. Okay, and it will handle scalar, vector, or matrix signals, and it is commonly used in feedback loops and system models. It will simplifies arithmetic operations in model. Okay, let me take two constant block. We'll just run this simulation. So I will keep this constant block value 10, and I will take one more constant block. I will connect it here, and this block value I will keep 5, and I will take one display just to see the result output. So let me run this. It will sum these two values. The result is 15. So you can also do this subtraction. I will make this sign as minus. The result will be 5. Here you can see the 5. So basically sum block is used to add and subtract multiple signals. So let me minimize the size and keep it aside. Let's move to next block, that is product. Just search product. Here is the block. Well, this block will multiplies two or more input signals, and it supports element wise or matrix multiplication, and it is ideal for gain chains, power calculation, and logic models. And we can also configure this with the different dimensions, scalar or vector values, and it is most commonly used in control systems and signal scaling. Okay, right now there are only two number of inputs, it is two. You can also multiply multiple signals, right now let it be two. So let's take two constant block again. Let me search constant. So right now the value is 1. I will keep it this time 15, and I will connect this constant here, and I will take one more constant block, and I will connect here. So this value I will keep it 3, and I will take one display. Now I will run this simulation. So the result is 45. So basically this block will multiply the input signals. So that's it. Let me keep this block aside, and let's go with next block, that is math function. So if you want to write any uh, MATLAB function or code, then you can use this math function. I think this is the wrong one. Let me search the right one. Math function. Yeah, I think this is the math function block. So here you will get the different options, like a function like exponential, log, and other square, power, different options you will get in this block. So yeah, and it supports many uh, like like sine, square, absolute value, and it will also support element wise or complex operations, and it is very highly flexible for different mathematical transformations, and it is used in signal processing and advanced modeling, and it will simplifies the model development by eliminating manual calculations. So if you want to find out any square root or any exponential value or any power value, so simply with the help of this block you can figure it out without writing or doing manual calculation. So this was about the math function. Let me minimize this and keep it aside. So next block is trigonometry function. So sorry for mispronunciation. So I think this one it is. Yeah, let me increase the size and show block name. Okay, basically this block will compute trigonometry function like sine, cos, tan, etc. And it supports hyperbolic and inverse trigonometry calculations. And it is useful for angle related computations in robotics and control. And it will accept the radians or degrees as input based on configuration, and most commonly used in motion systems and oscillatory models. Well, this was about the trigonometry function. Let's keep it aside. And now let's go with logical and rational operation. So there are some blocks which are useful for logical and rational operation. Let me type the name logical and irrational rational operations. Okay, enter, increase this size and keep it here. Okay. So the first block name is logical operator. If you want to perform any and or operation, you can use this logical operator actually. So there is option operator, you can select or NAND, XOR, so not gate also you can select. So different logical operations you can perform with the help of this block. So let's go with one operation and. So I will take two constant block again. Okay, I will make this as 1, and one more constant block I will take. I will make it as 0. So during AND operation, so when one input is 1 and another input is 0, the result is 0, right? Okay, let me run this. Here you can see 0. When both the inputs are high, then the output is high. Well, this was about the logical operator. I will delete these inputs and I will keep this aside. Okay, let's go with the next block, that is relational operator. Relational operator. Okay, relational operator. Let me double click on this. So here you can set the, you can you can compare the two signals. So if you want to compare any two values, suppose let me select equal to equal. Okay, just increase this size. Let me increase. I will take again two constant block. Okay, just okay. I will set this value as 5. Okay, and I will connect this to one of the input, and I will connect this second constant to the other input. Now the both the inputs are equal. The output will be 1, I guess, right? So I have selected uh okay, rational operator as equal to equal to. So let me run this. The output is 1. Suppose if here you can see not equal to, you can also select. Now the output will be 0, and you can also select greater than and equal to, lesser than and equal to. So let me select greater. So this one I will keep it 4. Now it is lesser than, so the output is 0. If you keep it 5, so it is greater than and equal to condition will get satisfied, so output is 1. So this was about rational operator. I will keep this block aside. Let's go with next block, that is switch. Okay, and about this block, let me explain you. With the help of this block we can compare two inputs using operations like equal to, greater than, etc., and outputs a boolean signal based on the comparison result. So the result is boolean value, and it is useful for threshold checks and conditional execution, and it is commonly applied in system triggers and safety checks. So this was about the rational operator. Let's go with the switch block. Okay, let me increase the size. Okay, basically it will select one of the two inputs based on the control condition. The control input determines whether to output the first or second signal. Okay, this signal or this signal, and it is useful for decision making and dynamic signal routing, and it will handle scalar, vector, and matrix input, and it is common in the fault tolerant, okay, and backup systems. This is most commonly used in fault tolerant and backup systems. Okay, we can also uh, connect some inputs for this block. Let me take one constant. Okay, I will keep this as 10, and okay, any random value I will connect to this switch block. So I will take two more constant block. So yeah, I will make it 5, and I need one more constant. Yeah, so here there is a condition. If the input is greater than 0, here you can see the threshold is 0. Here you can actually change the criteria. Right now it is the input is greater than threshold. Threshold is 0 and the input is 5. Yes, the input, this, it will check this condition. The input, the 5 is greater than 0. So output will be 10. Okay, if this condition satisfies, this will be the output, and if this condition fails, then this will be the output. So let me save and run this simulation. Here you can see now it is 10. Let me fail this condition. Okay, I will make it 0. So it is not greater than 0, right? 0 input. Now the output will be 5. This is how you can utilize the switch block. So basically it is used for decision making and dynamic signal routing. So let me delete this input and output blocks, and okay, minimize it and keep it aside. Okay, let's go with the next block, that is multiple multi-port switch. So it is similar to switch block. Okay, it is almost similar to switch, where it is, yeah, switch block with multi ports. Okay, so basically it selects the one of the multiple inputs based on the control index. The control input is typically an integer indicating the uh, chosen input. It simplifies the signal routing in complex systems, and it supports the scalar and vector signals for dynamic selection. And it is very useful in multi-mode systems and reconfigurable designs. Okay, this was about the multi-port switch. So based on index, it will select the multiple input. So let's try this. Okay, I will take few constant blocks. Okay, right now I will select it 1. So index it is 1. Okay, I will take few more constant blocks. So this, yeah, done. I will connect it. So when index is 1, let me send output as 10. When index is 2, let me send output as 20. When index is others or 3, then 30. Let me connect one display at the output and run the simulation. Right now the index is 1, so that output is 10. So let me change this to 2, right? Now the output will be 20. And if I change the value to some other value 3 or 6, guess what will be the output? It will be obviously it should be between 3 1 and 3. So we can't go above 3. Let's keep it 3. So it is 30. If you want, you can also increase the number of data ports. Right now it is 3. Okay, and you can also explore some more options. Well, this was about the multi-port switch. Let me delete the input blocks and output. Yeah, okay, I will keep this block aside and let's go with next blocks. Next block is compared to 0. Compare to 0. So if you want to compare any input signal, whether it is equal to 0 or greater than 0, then you can use this block. And here you can also change the uh, values operators. If you want to see whether the input signal is equal to particular value or not, like equal to 0, not equal to 0, okay, less than 0, less than equal to 0, and so. So basically this block, it will compare an input signal against 0 using rational operators and outputs a boolean signal for logic control. It simplifies common checks like positive, negative over 0 values and useful for triggers and conditional logic. And it will eliminates the need for additional blocks for 0 check. Basically, if you want to check any signal whether it is 0, positive or negative, then with the help of this block you can check the particular signal. Well, this was about the compared to 0 block. Okay, that's it. These are the different blocks which comes under logical and rational operators. Let's go with some other set of blocks that related to signal routing. Okay, let me type signal routing. Okay, and let me increase the size of this text, and I will keep it here. Okay, the first block name is which comes under signal routing is MUX. MUX. Okay, this is the MUX block. Basically, it will combine multiple input signals into a single composite signal. It creates a vector from scalar or vector inputs. Useful for signal bundling in models with multiple signals. It simplifies input handling for subsystems and functions, and it is common in multi-channel systems and dynamic models. So if you want to combine multiple input signals, then you can use the MUG. It's basically many to one. Let's connect to constant block. So basically you can just check the output. Okay, it will combine two signals, multiple signals. Here you can see 1 and 1. So if you want to combine multiple input signal, then you can go with MUX. And let's reduce this size and place it here. Okay, next block is demux. So it is one to many. If there are if there is one signal, like if you want, suppose there is a mux and it has combined multiple input, again you want to go back with multiple signals, then you can use demux. Actually, we can do combine this. Okay, let me undo it. Okay, here I will connect the demux. So output of mux, I will connect it to demux, and we can actually connect to display. Okay, year one and year one, just to check the output of tmux, and one more we will take and we will connect here. We'll see the output of mux. I will save this simulation and I will run it. Here you can see the result of demux. So basically it will split the composite signal into individual signal, and it will extract the element of a vector signal into separate outputs. It is very ideal for processing individual channels of a composite signal, and it complements the mux blocks in signal flow management. It is used in subsystems requiring separate channel processing. So well guys, this was about the mux and demux. Let me delete these all additional things. Okay, okay, and I will keep it aside. The next block is selector. Okay, let me search selector. So this is a selector block. Basically, it will extract specific elements or rows or columns from a vector or matrix. And it is very highly configurable for dynamic selection based on indices. Simplifies operation on large data sets or signals. Useful for selecting data subset in signal processing, and it supports real-time reconfiguration during simulation. So basically, if there is any input signal with the vector or matrix, and if you want to extract particular index, then with the help of this selector, you can do it. Okay, you can mention the particular index of vector or any dimension, like you can add it. So you can extract the particular value. So this was about the selector block. Let's go with next block, that is bus selector. Bus, I think creator, yeah. Let's go with bus creator. So this is block. It looks similar to mux, but there is actually there are difference between mux and bus. So we will discuss it in further. So this is the bus creator. It combines the multiple signals into a bus for organized routing. It allows mixed signal types including scalar, vector, and matrices. And it simplifies IRTL model design with the structured signal, and it improves model readability and modularity. And it is commonly used in complex systems requiring grouped signal. So in mux you can add multiple signals, you can combine multiple signal of same data type, but in case of bus selector you can combine multiple inputs of different data types like scalar, okay, any type of mixed signals you can add it. So this is about the bus selector. So the working will be almost similar to the, okay, mux. So let's not run this, and next comes bus selector. So it is similar to demux. So it's almost looks similar to demux, but again, you in case of bus selector, you can combine multiple signals of like different data types, signal types, including scalar, vector, and matrix. So this was about the bus selector. It will extract the specific signals from a bus. It allows selection of named signal for processing. Suppose let's take one example of battery. So if there is any measurement, So we can take this battery. I will give you example. You you can select particular signal. So just connect it to measurement block. So click on this. Here you can see you can select the specific current, voltage, and associative value of battery. Okay, you can by default there are some signals you can delete it. So if you want at least one signal, okay, if you want to see add the current value, just add it. So here you can see. So this is about bus selector. Now let's go with the control flow blocks. Okay, let me type control flow blocks. Okay, and yeah, I will increase this size of this text and I will place it here. Okay, the block which comes under control flow are if. Okay, let me search if. It's just like if else statement. Okay, this block it will execute conditional logic based on specific condition, and output control signals to the other block based on true or false evaluation, essential for decision making in models. It supports multiple condition for complex logic, and in common state machines and event driven system it is used. So it is basically if block. So if else condition, basically if you are well with the C language there is if else. Okay, so it similarly same thing is available in MATLAB Simulink in terms of block. So let's keep it aside. Then let's go with other block, that is if action. So if condition satisfies, then so this is the if action block. It will execute a specific subsystem based on the condition from an if block. It reduces the need for multiple independent subsystem. So basically it will reduce the need. So same operation if you want to perform without this block, then you need to design multiple block subsystems. So it will reduce the size, and it will also reduce the complexity, and by the way it will improve the efficiency by activating only relevant parts of the model, and it supports modular design for conditional processes, and it is used in fault handling and event driven operation. So so yeah, this is about the if action subsystem. Next one is for iterator subsystem. For iterator subsystem. And guys, by the way, you can also read blog on this topic. I will provide the link in the description. If you don't want to watch this video, you can also read our article. By the way, for iteration subsystem, it implements a loop within a subsystem for repetitive execution, and it executes a block or series of blocks for a specified number of iterations, and it is useful for iterative computations like summations or algorithms, and it is configurable for fixed or variable iteration counts, and it is common in data processing and optimized task. So this was about the for iteration subsystem. These all comes under control flow blocks. Okay, let's go with continuous and discrete systems. So there are blocks which comes under continuous and discrete systems. Okay, let me save this. So first block is iterator, sorry, integrator, my mistake. So this is the integrator block. It performs the continuous integration. Okay, basically it performs particular integration of input, outputs, the accumulated value over time, and it is used for modeling systems like velocity from acceleration. It supports initial condition for accurate simulation, and it is common in control systems and dynamic models. So it is just, it will do continuous integration. And okay, this was about the integration block, and let's go with next block, that is discrete time integrator. Let me search discrete time integrator. Well, it computes discrete integration of sampled signal. This block will do integration of continuous signal, and this block will do integration of discrete signal. Well, output accumulated value at specified time steps, and ideal for digital control systems and sampled data analysis. And it allows customization of sample time and initial value. You can customize the sample time and initial value, and it is used in discrete time PID controllers and filters. Well, the next one is the transfer function. Transfer function. Yeah, I guess this one. It represents a system in a Laplace or Z domain, and it models dynamics using numerator and denominator coefficients. It supports both continuous and discrete time systems, and it is ideal for linear systems and control design. And it is commonly used in system identification and tuning. So again, you can customize the parameters here. Just double click on that block. Well, next one is the state space block. State space block. Okay, this is the state space block. Okay, you can also set the initial parameters for state space, ABCD values. Basically, it models a system using state space representation, ABCD matrix. It provides a compact and versatile way to simulate dynamics. It supports multiple input, multiple output systems used for advanced control and observer design, ideal for representing high order and couple systems. Okay, this was about the state space. And next one is PID controller. So I think, wait for a few seconds, it will load. Yeah, this is the PID controller block. It implements proportional integral derivative control logic. It provides precise control over system dynamics. It supports real-time tuning of gains, PID, essential in automation, robotics, and dynamic systems. And it is configurable for continuous and discrete system control system. Okay, just double click on this. You can find the option for continuous time and discrete time, and you can also customize the PID values. Well, this was about the PID controller. Let's go with the next one, that is signal processing. Uh, Okay, this is the topic, signal processing. Again, inside signal processing, there are some blocks related to signal processing. Let me explain it one by one. So I will keep this title here, signal processing. Well, the first block name is FFT. Okay, this is the FFT block. Basically, it computes the first Fourier transform for frequency domain analysis. It converts time domain signal into frequency component. It is useful for analyzing signal and harmonics, signal harmonics. It is useful for analyzing signal harmonics, and it is ideal for vibration audio and RF analysis, and it supports real time and bench processing. So here you can set the many options are there. You can set based on your need and your specification. Next one is the filter. The block name is filter. Yeah, I take this one. Let it load. Maybe it will take few seconds to load. So basically you can apply low pass, high pass, band pass, and custom filter with the help of this block. So it is taking few more second, I guess. Let's wait. Okay, this one is the filter block. Basically, it applies low pass, high pass, band pass, and custom filter. You can apply with the help of this block. Okay, here you can set the low pass, high pass, band pass, and band stop filter. And it removes, basically, it will remove the noise or unwanted components from signal. It is, and it can be configurable for continuous and discrete system, so you can change it to continuous and discrete system. And apart from this, it is essential in signal processing and communication system, and it is most commonly used in audio, biomedical, and sensor signal conditioning. Well guys, these are the some of the most commonly used Simulink blocks while developing or modeling any system. Well, and if you want to read article on this topic, the link is in description. Go and check out. And if you really like this video, please share it with your friends and any office colleagues so that it can help him to learn about MATLAB Simulink. Well, guys, thank you for watching this video. Have a great day.